In the name of Allah, the most gracious, most merciful. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a partner and family. Please subscribe and share our channel if you haven't done so far. We as a team can convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition. Thank you very much for your precious time. Okay, we are still discussing smart grid control challenges. So far we have completed a 3 lecture. Today we are going to run a complete trail on lecture number 4 on smart grid control challenges. Before my lecture, I used to read a Quranic verse, Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli rabbi zidni ilma. Okay, before my lecture, I express my deep gratitude to Professor R.K. Agarwal, Professor Dr. Abdul Ati Idris. Dr. Abdul Ati Idris passed away in 2016. He was my mentor, external supervisor during my PhD. Professor Dr. Muhammad Afzal Haqqan from VCNED, UET Karachi and NFCIT Multan. Professor Dr. Nad Mohan, Minnesota University. Professor Dr. Florin. Professor Dr. Muhammad Tajammal. Professor Dr. B.S. Chowdhury, Dean, MUET, Jamshoroo, Pakistan. Professor Dr. Nasir Ali Mahdi. Professor Dr. Akhtar Kalam, Head of Smart Technology from Victoria University, Australia. Professor Dr. Suhail Aftab Qureshi, former Dean UET Lahore, Pakistan. Professor Dr. D.P. Kotahari, former VC IIT India. And Dr. Rana Abdul Jabbar, CEO ADP, Pakistan. Smart Grid Operation and Control Challenge Introduction, Lecture number 4. The Smart Grid Operation and Control Challenges Model. This is my 100 lecture plan. On my next slide, I will give you a brief about what is my plan. Before my lecture, I will give you highlights, lecture number 1, 2, 3, what we have discussed so far. First, we discussed electricity required for our civilization, electric power functionality, energy efficiency from generation to consumptions. Then we discussed ultimate goal of the smart grid. Power system infrastructure development, why we need it and how to do it. Power system complexity, power system limitation, when it's occurred and what were the solutions. Reactive power significant and management. So then challenge to manage reactive power, and there is a key elements and critical parameters. Then we will have discussed balanced reactive powers and challenge at AC power systems. These all elements we have discussed lecture number 1, 2, 3. Please explore and know more about what we have delivered so far. Okay, so today we will run a complete trail on lecture number 4. Before starting lecture number 4, on my next slide I am going to brief about my 100 lecture plan. These will be delivered 8 to 9 months. This is my 100 lecture plan. These will be delivered within 8 to 9 months. Okay, what basically my plan? So I will give you a brief about understanding a fixed concept technology. What is a concept? Then we will discuss a power semiconductor devices, voltage source converter, self and line commutated current source converters, SVC and STATCOM operations, static series compensators, static voltage and phase angle regulators, combined compensator UPFC, special purpose fax devices of controllers, and application. We will discuss few example. The fax devices already implemented in United States. What is the ultimate goal of fax technology or smart grid? Shaping the global energy delivery, fax on resolving grid locks and delivering clean and poor energy. That is the plan. In order to deliver, shape the global energy delivery, faxed on resolving grid, delivering clean and poor energy. Okay, on my next slide, I'm going to give you a key takeaway points. Dealing with a thermal limit, it will be the first segment. Second, increase transmissions conductor current carry capacity, DTCR, dynamic thermal circuit rating technology. Before my lecture, we will give you a highlights or recap lecture number 1, 2 and 3. Okay, I express my deep gratitude to all faculty members, student and leadership, in particular VCs and deans of the universities as listed here. UET Lahore, NFC Multan, RCT Gujranwala, Mehran, NED Habib, NAST, International Research, Karachi Electric, Distinguished Lecture, IEEE Qatar Sections, University of District Columbia, University of Texas Arlington, Texas Tech University, University of Bath, Qatar University, Texas A&M Qatar, University of Granada, University of Salamanca, COMSATS Abbottabad, City University Peshawar. Okay, as we have discussed lecture number 1 and 2, just we are going to give a highlight what we have discussed earlier. Basically, what are the key elements? Why we need a smart grid? Smart grid evolutionary development, fundamental approach for smart grid operation and challenges. So, technically, what are the driving factors which we need to consider in order to deliver the required results? First boundary is called the grid condition and requirements. This is the first operating boundaries we need to understand and to determine its criticalities. So what are these criticalities? Variable power supply, integration of distributed resources, increase distance between resources and load. And number 2 is called the operational factors. What are the operational factors? That is operational factors or operational factors boundaries. Greater transmission network complexity, aging infrastructure and lack of expert and high power delivery. Okay. Then number 3, external inferences or external boundaries. That is what we need to do it. So what it demonstrates, first, a legal and regulatory framework, integration of renewable energy resources, CO2 reduction and energy efficiency. In order to deliver the result or to operate your power system within their operating boundaries, what we need to do? A complex grid structure required, a smart solution. Okay. Now, just a recap, we have also discussed in my lecture number 1 and 2 as well. What is basically a demonstrate of fundamental characteristic of a smart grid? What are the smart grid fundamental characteristics? First is self-healing. What do you mean by self-healing? The grid rapidly detects, analyzes, responds and restores. That is important to understand. That is first key elements or key deliverables from the smart grid, self-healing. Number 2, empower and incorporates the consumers. That is the second elements of the smart grid. Ability to incorporate consumer equipment and behavior in grid design and operation. Number 3, tolerant of attack. Very important. Number 3 as well. Grid mitigates and resilient to physical and cyber attack. Number 4, provide a power quality delivery. Needed by the 21st centuries, users are based on CMBA curves. Grid provides a quality power consistent with consumers and industry needs. Number 5, accommodate a wide variety of supply and demand. That is very important, that you have a different type of demand and supplies as well. Grid accommodates variety of resources including demand, response, combined heat and power, wind, photovoltaic and use efficiency. So last year fully enabled and is supported by the competitive market. That is the last attempt from as far as the smart grid is concerned. So these are 6 deliverables must witness when we are going to implement a smart grid operation control challenges. Okay, in my earlier slide, we have discussed a characteristic of smart grid. Okay, what are the characteristics of smart grid? It demonstrates that a self-healing, empower and incorporates the consumers, tolerant of attack, provide power quality, accommodates a wide variety of supply demand, and fully enable it's supported by the competitive markets. In order to deliver these 6 segments, what we have to do, a technology is the option for a smart transmission or smart grid. Okay, what technology can do? Increase a transmission capacity, number 1. Number 2, maintain a power delivery stability. Number 3, manage real and reactive power flow. Number 4, improve reliability and resiliency. And number 5, efficiency of a transmission grid. So that 5 elements, 5 key elements can be witnessed by implementing a technology. That's why technology is an option for a smart transmission or smart grid. Okay. Now, what technology can do further? First, manage a power delivery flow and dynamics, number 1. Number 2, monitor a dynamic thermal circuit rating. Synchrophases wide area monitoring, protection and control. That's a second elements. Number 3, dealing with a power system dynamics from the root cause, not the effects. Okay. Number 4 here. So what it demonstrate here, number 4. So power electronic based controller, for example HVDC, fax technologies, with and without energy storage. So these are 4 options or can be witnessed by implementing a technology. Okay, we have a traditional electrical power system transmission system. Now we will provide how to convert from traditional to unconventional or smart solution or smart technology. Okay, technology option for a smart transmission system, smart grid. As we have discussed in our earlier slide, so dealing with the thermal limit, we have 2 options in order to address the thermal limit. First, we can use a dynamic thermal circuit rating technology, number 1. And second, we can use high temperature low sag connector. Okay, to address a powerful control and system dynamics, the second problem or second issue, we can use a power electronics based transmission control, fax and HVDC technologies, reactive power management, so segmentation and grid shocks observers, energy storage, wide area monitoring, protection and control, synchrophases technology. These have 5 options in order to address power flow control and system dynamics. Okay, now dealing with the thermal limit. So first we can use a dynamic thermal circuit rating technology. It can help 10 to 15%. Okay, for example, this is my thermal rating here, and this is my stability limit for the cell, and this is my cell, and this is my uncontrolled power flow, and this is my unused capacity. Okay, by implementing dynamics of thermal circuit rating technology and high temperature low sag conductor, we can address thermal rating and can use a maximum available capacity of power transmission system. Okay, now if we need to increase our transmission conductor current carrying capacity, so first we have to work on to implement a dynamic thermal ratings. Number 2, new conductor high temperature low sag. So that is our 2 options we can implement in order to address thermal rating, and number 2, high temperature low sag conductor in order to carry more current. Okay, so the increased transmission conductor temperatures, the conventional ACCR aluminum core steel reinforced conductor, so causing aligned sagging, decrease of clearance, loss of conductor strength and annealing. So if you can see here, it will increase the clearance. So the conventional ACR aluminum core steel reinforced conductor line sagging, so it has a more sag, decrease of clearance and loss of conductor strength and annealing factors. It will cause as far as the conventional conductor is concerned. Okay, DTCR dynamic thermal rating here. So what it basically demonstrate here, so this will lead to increase the thermal limit from 10 to 15%. So what is the idea? The idea to monitor the system performance in real-time operations. What we have to monitor? Line tension, weather condition, temperature of the conductor, and dedicate telephone lines or cellular telephone links permit remote monitoring system here. And then static thermal conservative criteria, low wind speed, high ambient temperatures. If you can see here in the graph here, left hand side, this is my rating in amps, and here is the number of 15 minutes periods, how many periods. Okay, if you can see here, the first, so the rating is 800 to 1500. So the period 1 to 10 periods. So the blue lines demonstrate the weather at 22-degree wind angle, and the green dots is showing the line tension based on the weather conditions. As ambient temperature change, what is the impact on line tensions? So as line tension vary, so there your thermal rating will vary accordingly. So then it can calculate by the heat balance. So Qgen plus Qsun equal to Q radiant plus Q conservative plus M Cp dt or dt. So it's mean, so if the ambient vary, so it has a great impact on dynamic thermal rating. So based on ambient temperatures or real-time monitoring, so the thermal limit can be improved or can be vary from 10 to 15%. If you see here, on my left hand side, I'm showing the probability density and versus current here. If you can see the load distribution here, the density was of 0.07 here, and it carry almost a 500 amps here. Okay, so then 600, and accordingly it's gone up. So over here it demonstrate here the warning provided if the rating is less than the load. So this is my static rating. So the dotted lines are dynamic rating. So in my dynamic rating, when the density is a 0.3 or 0.4 here, so 0.4, and it can carry 900 amps. As density reduced, so it can go up to 1100 or 1200 amps. So mean ambient temperature has a great impact on a loading area or thermal ratings. So as ambient reduce, so you can load it can be loaded more. So probably, so it demonstrate is temperature has a huge impact in order to overcome thermal limit of the conductor. Okay, a smart idea for time ahead generation scheduling. What is the smart idea? By using a C3 conditionally committed capacity for overhead transmission line. Smart idea for time ahead generation scheduling. Okay, now if you can see here, the hourly conductor capacity here, it demonstrate here amps versus day of the year. This is my amps and this is the day of the year. So how much the hourly conductor being loaded or conductor can carry the current. Okay, now in my this graph, if you can see here, this is my amps rating and this is my occurrence of print styles here. Okay, now the currently used, this is the area which has been used. So by implementing a C3, so the operating regime will change. So 10 to 20% more capacity, and it will remain 90 to 95% of time here. So in similarly here, avoid overloading a conductor, and it will act 0.5% of the time with static rating. So mean if we implemented a C3, so what we can have, we can use 10 to 20% more capacity, and system remain within a operating envelope 90 to 95%. And secondly, it will be not overloaded with static rating. So the conductor will be not overloaded with a static rating. Okay, high temperature low sag conductor. So the conventional SSR aluminum core steels in enforced conductor here. Heavy low ampacity high mechanical allocations, new high temperature low sag composite conductor. So low weight, high ampacity, high strength. So it will create a low clearance if we used new high temperature low sag composite conductor. It will help in order to deliver the results. Okay, now on my next lecture we are going to discuss a powerful control and system dynamic by implementing power electronics based transmission control, fixed and HVDC technologies, reactive power management, segmentation and grid, shocks observer, vision energy storage, wide area monitoring, protections and control, synchrophases technology. Okay, now today we have discussed a three topic. First, we have discussed dealing with thermal limit. Second, increase a transmission conductor current capacity. Number 3, DTCR, dynamic thermal circuit rating technology. My topic is still continue. On my next lecture, we are going to discuss generation 1, 2 and 3 fax technology or fax devices. Okay, these are references, the paper which I have published in different conferences and journals. Thank you very much for your precious time. Together, everyone achieve more. Please don't hesitate. Send me your feedback and comments. t.masood.dr@bath.edu. Please stay at home, safe, inspired and blessed. Thank you very much again for your precious time.